Okay, so in this lesson, we're going to build on the concepts that we talked about in the last lesson of our secant line and our tangent line slopes. And so we're going to use that slope of the tangent line to actually calculate that slope using limits like we've done in our last unit. So here's what we're going to do. We're going to first talk about the secant line, which is the average rate of change, which we're familiar with. So we know that the average rate of change is the change in y over change in x. This little triangle here means change or difference in y over difference in x. And so I'm going to label these points. I'm going to call this one C, f of C. And this one would be x, and the y value would be f of x. And so whenever I am talking about the change or the difference in y, it would be f of x minus f of c over x minus c. And that is the slope of the secant line. All right, so we're going to build on that definition of slope so that we can talk about the slope of the tangent line. All right, so the slope of the tangent line is going to help us find the derivative. So the derivative and the slope of the tangent line are going to mean the same thing. The instantaneous rate of change is the same as the derivative, which is the same as the tangent line. So let me kind of show you what we're going to do on this graph, and then we'll talk about how we're going to do that mathematically. So what we want to do is bring this point closer to the point where we want to find our instantaneous rate of change, or our tangent line. So I want to bring this y value down, or bring the x value in closer to c, because the closer I get it in here, the closer my slope, my secant line slope, would be to the instantaneous slope. So we want to bring in the x value, which would bring down the y value. So what we're doing there is called the derivative, and this is the notation that we're going to use for the derivative. And we are going to be finding the slope of the tangent line at x equals c, which is going to be our derivative. Now what we're going to do is we're going to take the limit as x approaches c. Well, that's what I was just saying. We're going to bring x in closer to c. X is going to be approaching c. We're just going to bring our y value down closer. And the closer we get, we know the better off we're going to be at finding the slope. I'm sorry, you couldn't see what I was writing down here. So the closer we get, the better off we'll be. So we're taking the limit of our secant slope. So we're still using that same formula. We're just bringing the x value in as close as we can get. And that's going to give us our derivative, or the slope of the tangent line. So I think all this will make more sense after we try one. Let's go down here and look at our first example. Get that up there. You can still see the limit. Okay. So it wants us to use this definition to find the value of f prime of c when c is 5. So they're really wanting us to find f prime of 5. And according to our definition, that means we want to find the limit as x approaches 5 of f of x minus f of 5 over x minus 5. So everywhere there was a c, we just put in a 5. All right, so now let's do a little more substitution here. We have the limit as x approaches 5. F of x is defined as this function, so we're going to put that in for f of x squared minus 8x plus 18, minus f of 5. Well, we need to find f of 5, so we're just going to plug 5 in here. 5 squared minus 8 times 5 plus 18. So we have 25 minus 40 plus 18, and that's going to give us 3. So f of 5 is 3, still over x minus 5. So now we have the limit as x approaches 5 of x squared minus 8x plus 15 over x minus 5. Okay, so we can't direct sub in 5. This is where our limit information comes in. So what we want to do now, let's scoot that up just a little bit, we want to factor so that maybe we can calculate this limit. So we have the limit as x approaches 5 of x minus 5 times x minus 3. X times x, 5 times 3, they both have to be negative to get 8, over x minus 5. And so now I can reduce and plug in the 5, so I have 5 minus 3 is 2, or the slope of the function at 5 is 2. Alright, so this gives us our slope of the tangent line. Well, they want us to write the equation of the tangent line. Well, remember that formula, the point slope formula that I gave you and told you we were going to be using a lot? This is where it comes in. We're going to write the slope of the tangent line at 5, when x is 5. So I know that x is 5, right? I know that when I put in 5, up here I got a y value of 3. Whoops. And I also found the slope of my tangent line, 2. So I'm going to use that information to write my equation. I've got y minus the y coordinate equals my slope times x minus the x coordinate. That's the slope of my tangent line. I mean, that's the equation of my tangent line. Alright, so what this means is that if we were to look at this curve, which we know is a parabola, and we graph this line, then on the parabola where x is 5, this line should be tangent. It should run right past the curve at that point. So in order to show you that, I went ahead and put this in the calculator. So this is just in the y equals screen. So we've got the curve. We have the equation of the tangent line that we wrote. I just moved the 3 over here to the end and put it in the calculator. So here it is. This is going to graph the parabola, and then it will graph the tangent line. There's our parabola. There's our tangent line. So at 1, 2, 3, 4, 5, which is right here, this is the line, the equation of the line that we just wrote. All right, so we have one more example. So I would suggest that you might want to try this one. And so pause your video for just a minute, try it yourself, and then come back and run through it and see if you did it right. But I'm going to go ahead and work it out. So we know that we're supposed to be finding the equation of the tangent line at c equals 4. So we're finding the derivative at 4, which is the limit as x approaches 4 of f of x minus f of 4 over x minus 4. Okay, so we have the limit as x approaches 4 of x squared minus 3x minus 4 minus f of 4. So we're going to plug in 4. So we have 4 squared minus 3 times 4 minus 4. So 16 minus 12. It'd be 4 minus 4 is 0. So this is just minus 0 over x minus 4. Alright, so we need to factor. The 0, of course, isn't going to change our number there at the end, so we're going to factor this. We have x, 4 and 1, minus 4 plus 1 over x minus 4. Our x minus 4s will divide out, and so now we can plug in the 4. 4 plus 1 is 5. So our slope of the tangent line is 5. So our point, our x and y values, we had 4 for x, and our y value is 0. And we have our slope of 5. So we have y minus our y coordinate equals 5 times x minus our x coordinate. Or we have y equals 5 times x minus 4. And again, you could check this on the calculator. You could type your equation in for the curve. You can type the equation in for the tangent line, and at our point, which is 4, when x is 4, this should run right past that curve, just on the outside.